Yes, very good morning. We will wait for 1 to 2 minutes, then we will start our session. Okay, so let's start our session for today. So yesterday we will discuss about uh, the quantization and the quantizational error. Okay, so and we will also discuss the different kind of quantizational level as well as the how we can represent the quantizational noise, and as well as we will also discuss the probability distribution having a quantizational error inside the process, whatever the process we can assign for a particular system. Okay, so that thing we will discuss yesterday, right? So a little bit brief about the quantizational error again. Okay, so the quantizational error is actually, I told you in the previous classes, that if we having a digital word which will be the finite word obviously, so for the conversion process in a analog to digital conversion, that the output we are coming having a finite resolution, right? So the digital output that can be assumed only for the finite number of levels, right? As our digital code should be finite, so therefore analog number must be rounded up. So that's why the quantizational error is also termed as a round of error. Okay, so since the quantization process is an approximation process for the conversion from the analog to digital conversion, right? So clearly it should be defined in the quantizational error, that we can also term this quantizational error as a round of error. So clearly we can state it that the quantizational level that we have a smaller values for rounding of particular error. Okay, so we will discuss in the previous lecture what will be the behavior when we are considering the analog input as a xt. We will considering the analog input as a xt and the discrete output as a yt, and what will be the quantizational error which will be defined as a et. Okay, so quantizational error is actually nothing but a the difference between the input signal, whatever the input we have entered into the system or into the process, that will be the difference between the input signals and the quantized outputs. That means the ET is equals to the XT. XT is an analog input minus of Y of t. Okay, we will also discuss the magnitude. Okay, so how we will calculate the magnitude of the quantization error and what will be the limit of the quantization magnitude of the quantizational error. That thing we will discuss in the yesterday. Okay, so and also we will also discuss the suppose we have a quantizer block, supposed to be, and we are giving the input as a xt, and we are giving the output as a yt. So for that cases, what will be my graph? Okay, input output characteristics. Okay, so if so today we will discuss about the some more about the quantizational error, and as well as we will also discuss about the noise and whatever the quantizational noise, right? So these things, and today we will mainly discuss on the data acquisition, right? The conversion and the distribution system in the digital control system, right? So this is the actually one more class is remaining for the module 1. Okay, so today and yesterday sorry, tomorrow I have another class. Okay, so then we will complete our module 1, right? So I think you have you have an examination, right, in this month, right? So I think it's a module 1 that will be your in your syllabus, right? So tomorrow, I think, or day after tomorrow, I will complete my portion of a module 1. Okay, so few things is remaining. Okay, in the module 1, one is a data acquisition system, and as well as the conversion and the distribution system. If the time permit, then I will again take one classes in the Saturday, so that you will what type of question you can avail from the module 1. That thing we will discuss in a Saturday if the time will be permit, if I'm available. Uh, During this time, right? So we will strictly go to the share section so that you will able to see my screen. So is my screen is visible? Yes.
Yes, sir.
Okay. Okay, fine. So now actually we will go to this section. So in the previous lecture, we will discuss this thing, right? What will be my quantizational noise, the probability distribution, and as well as how the probability distribution that will be in a graphical format. Okay, so that means what will be the input-output characteristics. Okay, so the probability distribution supposed to be, it will be defined as a PE, and what will be the equation for the probability distribution, and what will be my the magnitude, what will be the magnitude of my quantizational magnitude of the quantizational error. So that thing we will discuss. Okay, so today if we have, I have already told this particular diagram where we have using this quantizer block. So again we will discuss this thing, right, according to the graphical format, right? So in this case, if I, yes, so if I draw, one second. Yes. So what we will, we have a quantizer, right? So quantizer block. We have a quantizer block. So we are getting the input to the xt, right? Which will be my input, analog input, and yt that will be my discrete output or the digital output or the quantized output, we can say, right? So someone is coming, I think. Okay, fine. So this will be your xt having a analog input, right? So and that will when it will flows through the particular output, and that will comes to the discrete discrete output, or we can say it should be the quantized output. Okay, quantized output. So my quantization error that should be calculating in in which equation, quantizational error, which will be defined as a ET, right? So ET is actually nothing but a my input signal xt minus of yt, right? That means my input signal and the difference between the input signal and the output signal. And what will be my magnitude for this case? So what will be my magnitude for this case? So the magnitude of this particular quantizational error, so the magnitude will be stated as a e of t, right? So that will be vary from 0 to what? Bolo, 0 to half of q, right? So that is actually the thing. So if we have a graphical representation having a different type of noise cancellation will be occurred inside the system, so for that cases what will be my graph? The graph should be look like this. So this will be my input output characteristics which we will see. So it will be considered as a x-axis and this will be considered as a y-axis discrete output. Okay, and your my analog input, right? So in this cases my signal that should be flow accordingly, right? So here we will see the signals that will be distributed in a according manner, right? So supposed to be, this is supposed to be your q, this is supposed to be your 2q, right? And if I stretch this equation, so this portion we can say this is your 2q, and this portion that will be your q. Okay, so and that portion will be 0. Again we have considering the negative plot like this, right? So this particular diagram or this particular structure or the characteristics will be shown actually what the analog input xt and the discrete output yt, the characteristics of. So this diagram or this particular characteristics will be defined as a analog input xt, the relationship between xt and discrete output discrete output y of t, right? So if we will reconstruct this particular characteristics, so it will be look like this. Okay, so if we reconstruct this characteristic, so it will be look like this way. So if I have a values of xt, and here we are putting the at the time interval t, and that should be 0. So that value will be my xt, right? So suppose we have a different values. Okay, so depending upon the different values supposed to be this, like that. Okay, so the signals that will be generated in the input output characteristics, input versus output characteristics. Okay, so signal will be generated in this particular pattern in a discrete form. Discrete form means, so this is supposed to be your one pattern, right? Supposed to be this is one pattern, this is the another pattern we have, this is the another signals. Okay, so this is the another signal, this is the another signal. Okay, like that, right? So if we stretch this value, then it will be look like this, right? So if we plotted this particular graph, okay, in a, so this will be your my supposed to be my input signal will be my analog signal. So xt, that will be my input to a particular quantizer. Okay, and yt is my output. So xt will should be like this, xt will be like this. So if I plotted a mark in a red manner, so xt would be like this. My continuous signal, my continuous signal should be like this. right? So so this will be my continuous signal, continuous analog signal. This should be my continuous NIOUS, continuous analog signal or analog input, we can say, which will be termed as a xt. Okay, and it will be converted when we are applied the quantizer block. Then it should be, we are coming, output should be your discrete output, so that should be your yt. So yt is actually what? Yt will be this will be the structure of a yt. Okay, so this value, this one. Okay, so that will be that value for the different time interval, right? So suppose this will be for the time interval t. Supposed to be, this is 2t, this is 3t, this is 4t, 5t, 6t, 7t, like that. Okay, so n to the power t, right? Or the, we can say that the small t, whatever. So t is actually the time period, how my signals will be distributed in a system, right? So this signal is actually known as my discrete signal or the quantized signal, which will be termed as a yt. Okay, so we are putting this xt value and the yt value in the same axis. Okay, depending upon what my period is, where t will be signify my time period of the, or the period of time. Okay, so how this particular signal, so we have a input signal of a system, okay, which will be your continuous analog signal, and that will be discrete output. We are getting the discrete output having a values of, having the block of the quantizer, right? So suppose we can say that in the previous in the previous lecture we will told you that, so in the previous lecture we will told you our value. That means suppose we have a very small values of, suppose we have a very small values of q. Okay, so q have a small value. So due to the q have a very small value, so the quantizational level, so the quantization, so we can say that the quantization level. Okay, so the quantizational level q will be very small. Okay, so as because we have value of q will be very small, so for that cases the level of the quantizational effect, that will be also very small. So what will be the effect in the quantizational error? That will be distributed in a uniform way, so uniformly between what. So suppose in the previous lecture we will discuss this thing, right? So this one. Okay, so this particular distribution, so et, that will distribute it. So suppose in this figure et will be distributed, uniformly between minus half of q to plus half of q. Okay, so that should be the uniform distribution of a particular error, and that particular error having a particular noise. So that is obvious. There will be the rough assumption there should have an arise some noise. So, however, so the quantizational error signal that have a very small amplitude. So, for that particular assumption, we will considering the first order differential equation, right? So in this case we can say that whatever my input is, that input will be quantized depending upon what the value of my q is and what the level of the quantizer is. Okay, so that is actually the main thing. Okay, and eventually we will also been said that the this probability distribution, that is also taken into consideration, which will be defined as a pe. So pe is actually what, as we will discuss, that will be half of q into e to the power t. So that should be your half of q into your e to the power t. So this PE is actually nothing but a probability distribution having a quantizational error in a system. So this is actually probability distribution. right? So that is that is the thing. So whenever we have a numerical analysis, so this particular equation, this equation, okay, so the previous equation, this equation is also you have to take into consideration when we have entered into the j transformation. So if I consider then the j transformation of this particular equation, so for that cases there should have the requirement of a et, right? So there should have a requirement of a et, right? So in this particular case, now we will goes into the part we will discuss the later on in the end of the session. That will be my quantizational noise, okay, which will be defined as a tau 2 tau square. Okay, so in this particular cases, the this one, that means the quantizational noise, the quantization noise, that will be also been termed as tau square. So it will be like this: whenever this particular noise which will be arise when we having a limit of whenever e to the power t that will be tends to 0. Okay, so if the e to the power t is equal to 0, so for that cases there will be some variation of the quantizational noise, right? So I think someone is again came. Okay, so here we will see that in the quantizational noise, we will see that the equation will be stated as your e, that means the exponential term. If we were having a Laplace transformation, so we will deal the Laplace transformation in the next module. Just you have considering this equation, this will be the magnitude whole square, right? So that will be the equation for the quantizational noise. So if we will simplify this equation, okay, so for that cases we have a values of minus q by 2 to plus q by 2 plus q by 2 epsilon square d of q. Okay, or we can write this way also: minus q by 2 divided by q by 2 plus q by 2 having a q square into dq, right? So if the quantizational level, so if we will simplify this equation, so how we will get this equation? So that will come if we simplify having a Laplace transformation or the integrational by parts, right? So for that cases my value will become the q square by 12. Okay, so that value will become in a such a way that supposed to be this will be your L square, having supposed to be this is your 1 by q integration of minus q by 2 into plus q by 2, right? So integration square d of lambda. Okay, so इसको अगर ये करेंगे, so if we have a Laplace transformation, so we will consider these things q by 2 q by 2. Okay, so it will come 1 by 3q, right? 1 by 3q summation of q, okay, summation of q having mod of minus q by 2 to plus q by 2, right? So that will come 1 by 3q, 1 by 3q, this value supposed to be q cube by 2 plus q cube by 2, right? So if I simplify this equation, that will come my q square by 12. So that thing is actually we are doing what? We are doing the integral operation of a particular quantizational noise having a values of q square by 12. So this will be the equation for the calculating the quantizational noise, where q will be defined as a quantizational level, right? Q will be defined as a quantizational level, right? So in this case we will see if the quantizational level q that is very small as compared with the we can say that the average amplitude of the input signal, whatever the input we are entering into the system, so then we can say that the variance of a quantizational noise, the variance of the quantizational noise is seen to be 1/12, is seen to be 1/12 of the square of the quantizational level. So if we will considering this thing 1/12 of q square, so okay, so that thing you should be remind, right? So that is the thing we will discuss in this part. Now in the next part we will discuss about the data acquisition, right? So the next part is your data acquisition, right? ACQUISITION, data acquisition, conversion, conversion between D to A and A to D, and the distribution system, and the distribution system, right? Okay. So up to this, is there any question in this part before starting the data acquisition? Because data acquisition is the final part in this particular module, nothing is left. Okay, so if you have any question regarding this, so please ask. Anyone? Ziaul, are you there?
Yes, sir.
Okay, do you have any question?
No, sir.
Okay, acha, Rahul, Rahul, Rahul Kumar, I think Rahul is not there. Rahul is there or not?
Yes, sir.
Okay, so do you have any question? This is understandable or not?
Yes, sir.
Okay, fine. Okay, फाइन. और कौन कौन है देख लेते हैं. ओके, स्वाति, स्वाति, आर यू देयर? Swati Sri.
Sir.
Okay, so it is understandable. Do you have any question?
Yes, sir.
So do you have any question?
Yes, a little bit.
So
No, sir. Right now, no questions.
okay, so whatever we have taught in the module 1, in the next class I will give you some questions from your side. Okay, okay, so कुछ क्वेश्चन तुम्हारे साइड से होना चाहिए, so that thing we will discuss tomorrow, right? So you jot down few questions that will ask to me, okay, so that we have an interaction part, right? Otherwise it will be very difficult. From one side we will taught, okay, and whether you should understand or not, so you jot down you will go through whatever we will taught till now, okay, you go through it, and everything which will be available in the YouTube, all the recorded materials that will be uploaded, we will upload in the YouTube. So you will check this. If you have any question, jot down this particular questions, okay, and you may ask this particular question in the next class. Has been tomorrow I have another class, okay, so then we will discuss whatever your question is it clear?
Yes, sir.
Okay, Ritesh,
Yes, sir.
Ritesh, are you there?
Yes, sir.
Okay, so is it understandable or not? Whatever I taught?
Yes, sir.
Because we are dealing with an online classes, okay, it will be not the chalk and duster class, so that you will interact with me in a physical way, okay, so please tell me where you will not be understand. If supposed to be, it may happen ki you may not be understand due to the online mode, due to some issues. If you are using if you are login using your mobile, so the screen will be very small. So for that cases you will told me. If you have any problem, if you have any problem regarding anywhere, supposed to be in which section you have getting some problem, then you will told me. Otherwise I cannot get your problem, right? So that I will talking like that, and again you will like this. Okay, so you will tell me from where you have it not been understand, then again I will told you in my way. Is it clear?
Sir, sir,
Ah,
uh, sir,
ah,
I
yes.
have doubt, little bit doubt in formula and derivation section, sir. When we
Derivation
use
section,
Fourier,
you are in the lateral entry, na, lateral entry, right?
yes, sir. When we use Fourier or Z transform, that which is not yes, sir, understandable, sir.
Yes, yes, definitely. So those who are lateral entry, I told you that you do follow, because after 2 3 days we are entered into the jet transformation and the Laplace transformation, where the big derivation will be there, and there will be the purely the mathematical calculation is there. Okay, so I have a suggestion to you, those who have a lateral entry, those who have lateral entry, you please follow the mathematics 3. Okay, so there will be the book which will be available in the Google, that the name is BS Grewal. Okay, so you follow this book in the mathematics 3. Okay, j transformation, Laplace transformation, Fourier series, and the integrational bypass integration. Okay, derivation, second order derivative, first order derivative, all those kind of things that will be implemented from the module 2. So that is why I told you, before starting the jet transformation, you need to understand what will be the basic formula, because there will be we have a only 45 minutes class, so it could not be possible we are again go to the mathematics section for calculation, right? So we will you will check in the mathematics book, in the mathematics way, there will be some formulas related to the Laplace and the Fourier transformation. Suppose what will be my Laplace transformation of 1 by s, okay, what will be the Laplace transformation of 1 by s square, right, like that. So this type of formulas that you will need. Okay, so you recapitulate the mathematics 3, that means Laplace and the Fourier transformation, very beginning, so that whatever I taught in the module 2, that thing you will comfortably you will do this thing, right? So that's why I told you, because there will be purely based on the mathematics. Okay, mathematics 3, j transformation, and in the module 3 there have a Laplace transformation, right? So these are the two main thing. Module 2 and the module 2 in the digital control system is a main part. So whenever, so we will only today, right now we will only discuss about the equations. Okay, so when we will deals about the Laplace transformation of a particular equation, Laplace transformation, then it will be very big, right? So there will be the huge derivation. So how this Laplace transformation will be, that's why the formula is needed, right? So you keep remind what will be the Laplace transformation of 1 by s, what will be the Laplace transformation of s square, right? So what will be the Laplace transformation of s, okay, so what will be the Laplace transformation of 1 by z square, right? So these things, that all the formulas, okay, I will share before starting the jet transformation, I will share some formula data regarding the jet transformation, and you will recapitulate all those things. Otherwise it will be very difficult whenever we have deals with the numerical analysis or the numerical problems, then it will be very difficult, because अभी तक तो कुछ numerical आया नहीं है, right? So in the next module we have a very big numerical. Okay, so that it will be very uncomfortable with you if you are not understanding the Laplace transformation, right? So that thing you keep remind. Okay, okay, Ritesh.
Yes, sir.
Okay, so if the time permit, I will show you. I will told you ki what the jet transformation is, what will be the basic necessity of the jet transformation for implementing the detailed control system. That thing I will discuss. But whenever we have to derive the equation, so for that cases you must requirement of the mathematics. So that is why I told you. I give you the, whenever we have getting some lecture in the data transformation, I will told you during the derivation what will be going on, that thing. But the basic equation, the basic transformation, you need to understand. Okay. So now we will discuss about the data acquisition, right? So the data acquisition is actually data acquisition, conversion, and the distribution system. Okay, so we can say that in a rapid growth of a digital computer, because abhi kya hai ki we have a maximum use of a digital computer, or we can say that the supercomputer normally we will use for controlling any such kind of action. Okay, whatever the action is, either we can use the PC, or we can use the digital computer, or we can use the supercomputer. Okay, so and that is necessary depending upon the rapid growth of the present scenario. Okay, so what we will say, that the rapid growth of the use of the particular digital computer to perform the digital control action. So both the data acquisition system, okay, so both the data acquisition system, this thing, both the data acquisition system and the distribution system, obviously distribution system has become a very integral part, or the very important part of an entire control system. Okay, so digital control system is actually based on the two different part. Okay, one is your data acquisition part. Okay, data acquisition part, and the another one is your distribution system part, right? So in case of an electrical engineering, you will know in the power system, the power system will be divided into the three different segment, right? So what are the power system will be divided? Three different segment क्या क्या था मेरा? Power system तो बड़े थे, I think probably.
Yes, sir.
So the
Generation,
power
transmission,
system, one is
Transmission and
your
distribution.
generation, transmission, and the distribution, right? So distribution. So each and every part there must have a digital control, right? So here also we have to implement the digital control. So for generating the power, we need the data acquisition system. Okay, inside the plant. Okay, so in the transmission also we have a requirement of the control structures. Okay, so there also there the requirement of the data acquisition, and obviously in the distribution system. Okay, in a particular power system, in a distribution system, that is here, that is there also, the distribution system having a particular data acquisition system is needs to be implemented in each and every portion of a power system. So that is why we can told that the inside the digital control system, that will be implemented also in the power system network also. Okay, so each and every system that will be needed for the data acquisition and the distribution, and as well as the conversion process. Okay, and this data acquisition and the distribution system is a very integral part, or the important part of any such kind of power system, or any such kind of digital control system, or any such kind of system, or any such kind of process, right? So we can say that the signal conversion, whatever the signal we are giving to the process, so that particular signal conversion which will be takes place in a digital control system, which will be involved in a following operation. So what are the operation we will taken into consideration for dealing the signal conversion? Okay, so we can say that the signal conversion, either it should be the analog to digital, or it should be the digital to analog. Okay, whatever the signal conversion is, so that we can say that the signal conversion, either it should be the digital to analog, or it should be to analog to digital. Whatever the conversion is, that takes place, that takes place that takes place in a digital control system, in digital control system in digital control system, which will involve the operation, like the operation. So what are the operation that will involve for a conversion of this particular signal in the digital control system? The operations are, the first operation we will discuss with in the data acquisition part, we will discuss about the multiplexing, multiplexing. Okay, and demultiplexing. Okay, so this will be the first involvement of the operation. Okay, second one is your sample and hold, right? So the third operation we will discuss about the A to D conversion. A to D conversion, that will be known as also the sampling. We can say that the sampling, or we can say that the quantizing, we can say the quantizing and encoding, right? And the number 4 operation, we will discuss the digital to analog conversion, okay, which will be known as a decoding. That thing we will discuss in the previous, very previous class. Okay, so the sample and hold this analog to digital conversion and digital to analog conversion, that thing we will discuss in the very previous lecture. We will not discuss this thing, right? Multiplexing and the demultiplexing. So we will discuss what will be the different kind of operation, what will be the aspect of this particular operation, of this particular four operation in a digital control system, right? So this is all those operation will be depends upon my digital data, okay, or the digital input, or the, we can say that the digital data acquisition system or the distribution system, right? So all those things we will discuss, but we will discuss in the next classes. I think you have another class from 11:30, so we will stop the session for today. We will discuss having in a brief the this particular four operation, okay, having a digital control system, right? So what will be the function that will be adopted in the digital control system, okay, in a data acquisition process, we will discuss in a next day, right? So these things will be only remaining, this fourth thing, okay. So there will be the few parts will be there, okay. So we will discuss in the next class, okay. Tomorrow I have to discuss, okay. So now we will stop the session for today. We will discuss tomorrow, okay. So thank you,
Thank you, sir.
okay.
Thank you,
So we
sir.
will stop the session for today. So everyone are requested to leave the session.